Okay, so let us do a little example, 8.7, on how to apply the equation of motion. Recall, the equation of motion is given by this. Sum of the forces is ma, or A is equal to the sum of forces over mass. Okay, so here's a nice little problem. We have a person sitting on a chair in an elevator. Okay, I've never seen this in my life. And, I've been in quite a few elevators. I've never seen this, but okay. So the person is sitting on sitting on a chair in an elevator. And it doesn't tell us what's happening in terms of acceleration. Okay? All it says is that, let's consider the forces. Let's try and do a free body diagram of, let's see. It says the forces exerted on the stool are a downward force of magnitude 60 Newton, okay? Because the stool is 5 kilograms. And so, so it looks like they are drawing a free body diagram of the stool. Okay, so it's very important that you identify what you are analyzing. So if you are analyzing the stool, then if we're calculating acceleration, we're calculating the acceleration of the stool, of the chair. Okay? So they say that there's 60 Newton, so the stool is 5 kilograms, so that means that there's a 60 Newton force due to gravity, okay, of the stool. Then we also have a person applying a downward force on the stool of 780 Newton. Okay, so that's also a downward force on the stool. And then of course we've got the force of the floor on the stool. That's the elevator floor. It's a normal force upwards of 850. Okay, so there's the free body diagram. And so what we want to do is we want to calculate the acceleration of the elevator. What is the acceleration of the elevator? Well, if you calculate the acceleration of the stool, you're going to calculate the acceleration of the elevator. And also, another thing is if you can calculate the acceleration of the person. Say now you redid this entire problem and you analyzed the person as your object. Then you can, if you calculate the acceleration of the person, it would be the same as the stool, it would be same as the elevator. But they've given us the inertia of the stool, so we are working with that. So let's apply this. Acceleration of the stool now, okay, is equal to all the vector sum of the forces acting on the stool divided by the inertia of the stool. Okay, so 1 over m, it's 1 over 5. And now this is the vector sum of those forces. We add these up because they're in the same direction, along the same line of action. We say plus 850, minus 60, minus 70. We add them up and we get an acceleration of plus 2 meters per second squared. That means that the person, the stool, and the elevator are all accelerating 2 meters per second upwards. Okay, so the elevator has an upward acceleration. Okay, all right, see you.